Okay, what we're going to be talking about today is what is a radian and how to go from degrees to radians and radians to degrees. Okay, so let's talk about right now in the unit circle. If I put a point right there, what's going to be that ordered pair? I'm going to call it a 1 and a 0. So we're just saying, I realize that technically that's at 1, 2, 3, 4, 5, 0, but we're just saying it's at 1, 0. We're going to call this 0, 1. Over here, we're going to call this -1, 0, and then right here in the unit circle we have 0 and -1. So you should already have this. Now, in degrees, let's talk about degrees. Right here, how many degrees from this initial side to this terminal side? So if I go from the initial side, which is right here, to the terminal side, which means where you finish, from right there, how many degrees have I gone? I've gone a total of 90. So you should have 90 degrees. This right here is 0 degrees. So we go from 0 to 90. We go to 180. We go to 270. And then eventually we get back to what? If we go all the way around the circle, we call that 360 degrees. If you go all the way around. But there's these things called radians that I want you guys to understand. And you should also have this on your unit circle. 90 degrees is considered to be pi over 2 radians. So I'm going to put pi over 2 radians right here. Okay? From 180 degrees, that's equal to what's called pi radians. So put pi rad. All right? And then right here, this is going to be 3 pi over 2 radians. So right now, here's some equivalent things that you guys need to know. All right? 0 degrees is equal to 0 pi radians. So if you would put that in your journal, okay? 90 degrees is equal to pi over 2 radians. 180 degrees is equal to pi radians. Okay? 270 degrees is equal to 3 pi over 2 radians. So what do you think 360 degrees, if we follow the pattern, what would 360 degrees equal? Two pi radians. Now let me try to make a connection from what you guys should already know. What is the circumference of a circle? Circumference of a circle is equal to what? 2 times pi times the r value, but the r value in this formula is called the what? Called the radius. What I want you guys to do is put 360 degrees always equals 2 pi times your radians, okay? 2 pi radians is equal to 360 degrees. So if I wanted to figure out what 1 radian was equal to, all I'd have to do is to divide both sides by 2 and a pi. So what is 1 radian? Always equivalent to 1 radian is equal to 180 degrees over pi. This is what I want you guys to do. Now that's approximately, I think it's like 57.3, but we'll do it in our calculator right now. Let's do 180 divided by pi. All right, 57.29, so 57.3 degrees. All right, so every time I say 1 radian, that's approximately equal to 57.3 degrees. So I want you to have this in your journal because that's going to help us in our conversion when we go from degrees to radians and from radians to degrees. This is super, super duper important. So write that down. So I'm going to scroll down a little bit. In your journal, if you want to, you can make an angle. You know what? Let's make an angle that's about 57. Let's do our best and make an angle that's about 57.3. Oh, well, that was close. That's pretty close. So right here, I'm going to put a mark right there. Move that out of the way. So this right here is equal to 1 radian right here, this angle. Ah, come on, you can do a better job than that. There we go. So guys, this angle right here is 57.3 degrees. So right here, that's 1 radian. Okay? From here to here. All right. So how do we use this information right here? All right? How do we use 180 over pi equals 1 radian? So right now, what I'd like you to do is I would like you to take 360 degrees, and we know what our answer is going to be. Our answer is going to be 2 pi. But how would we convert it if we start out with 360? So if you're going from degrees, so here's what I want you to do. We're starting with degrees, and we're going to radians. Here's the process. You're going to multiply that by pi over 180. All right, and that will give you your radian. So when I multiply 360 times pi over 180, you got 360 over 180 times pi, but 180 goes into 360 a total of twice. So you have 2 pi radians. So here's what I want you to do. Put a box, open up a parentheses, put pi over 180, and simply put right here whatever degrees that you have, put in the box and multiply it by pi over 180, and that will give you how many radians you have. But when you do it, don't multiply it to the pi. Just basically take that and just divide it by 180, and that's going to be what your answer is. So here we go. Quick little response. What if I said 55 degrees? Well, this would be 55 pi over 180, but we need to simplify this fraction. So I would just do 55 divided by 180, hit the math button, press enter twice, and I get 11 over 36. So my final answer would be 11 over 36 pi radians. There's a little extra dot that doesn't need to be there. Try to erase it without erasing everything else. There we go. So this would be my answer in radians. If I started with what? 55 degrees. So how do I do the other one? Radians to degrees. Radians to degrees is really easy. Now we're going to go from radians, and what are we going to? Degrees. All right. So what you're going to do is you're just going to multiply it by 180 over pi. So this one's pi over, if you're going from degrees to radians, you multiply it by pi over 180. If you're going from radians to degrees, you multiply by 180 over pi. So let's say you had 2/3 pi radians. What would that be in degrees? 2 times 180 is 360 divided by 3. These pi's will end up canceling out. So if I have a pi in the numerator and a pi in the denominator, they cancel out. 3 goes into 360, a total of 120 times. So this is how many degrees is 2 pi over 3. So what do I want you guys to have in your journal? I want you guys to have some examples that you know how to go from, oh, that's a circle. I don't want a circle. I want a rectangle. There we go. I want you guys to know how to go from degrees to radians and from radians to degrees using pi over 180 and 180 over pi. So here we go. If you would, please. Theta right now is saying theta is what? 8 pi over 9. So all you have to do is take the 8 pi over 9, and we're going to multiply it by 180 over pi, so that the pi's will cancel each other out. Now, 9 goes into 180, a total of 20 times, and 8 times 20 is 160, and that's what's going to be my degrees. But in the calculator, here's all you would have to do in the calculator. You take 8 over 9, and you multiply it by 180, and that's it. Take 8 over 9, multiply it by 180, what do you get? 160. What did I not do? Don't worry about putting pi in your, because those are going to cancel each other out. So right here, I'm going to write 160, and we'll move on to the next problem. So we went from radians to degrees. Here we're going from degrees to radians. So what am I going to do when I go from degrees to radians? You start out with your degree. You multiply it by pi over 180. What's going to end up canceling out these 180s? What are we left with? Pi. So when it asks you to express your answer exactly, what do you want to put right here? Pi. You want to put pi. Not 3.14, whatever the approximate value. Literally type in, oh look, pi. Okay, here we go. Theta is 17 pi over 18 radians. So this one, I'm going to go 17 pi over 18. But now I'm going to do 180 over pi. Now this 180 over pi, these pi's will cancel each other out. So literally in the calculator, all you got to do is do 17 over 18 times 180. Now 18 does go into 180, a total of 10 times, and 17 times 10 is 170. But let's say you didn't notice that. You could still put it in the calculator and type in 17 divided by 18 times 180, and you still get the same answer of 170. Okay? All right. And last but not least, we're doing 310 degrees to radians. So if we're going from 310 degrees to radians, we start off with 310 degrees, and you have to multiply it by pi over 180. So you get this 310 over 180 multiplied by pi. Now this 0 will cancel out that 0, so you're going to be left with the simplified fraction of 38 over 18 pi, and I'm going to have to type that in very, very carefully. So let's say you're like, all right, 310 divided by 180, and then you hit the math button, press enter twice. You still get what? 31 over 18. So what do I have to type in right here? I got to make a little fraction guy, put 31 over 18, but then next to it, not in the denominator, but next to it right here, see right here? You got to put a pi here. Don't you dare put a pi down there. That's wrong. Make sure you put it to the right of it. Otherwise, they will mark you wrong. So let's take a look at something real quick. Let's look at the pattern. Degrees to radians. What do I multiply by? Pi over 180. Radians to degrees, 180 over pi. Degrees to radians, pi over 180. Radians to degrees, 180 over pi. So that's the pattern that I want you guys to work on. Please go ahead and work on that now and get 100. All right, for our next one, what we're going to be talking about is the unit circle with radians, everybody. The unit circle with radians. So could you please, right now, all you got to do in your journal is just title unit circle with radians. You don't have to draw this beautiful circle. You don't have to do it, but we do need to review this. Ready? If I have an x coordinate and a y coordinate on the circle, the x coordinate is always going to be the cosine of theta, and the y coordinate will always be the sine of theta. So just remember that. Cosine of theta is the x, sine of theta is the y. Now check this out. Can everybody see how this little circle in our problem, it went from here all the way around? So in our particular problem, what is our value for theta in radians? Our value for theta in radians is what? 3 pi over 2. What would theta be in degrees? How many degrees is it from here all the way around? What would you guys say? 270. So yes, in degrees it's 270, but now in radians it's what? 3 pi over 2 radians. So right now it says, right? What is the value of the y coordinate of point what? Point A. So you guys ready? We're going to use radians this time, right? We're using radians. So what would be the value of the y coordinate? The sine of what? The sine, and what's theta equal to? The sine of 3 pi over 2. That would give me the y coordinate for A. It's the sine of theta. That's the y coordinate. So I'm looking for the what? The sine of 3 pi over 2. Do, 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 do. Nope, 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 nope. Yay! You guys see it? Right there. Nailed it. All right, here we go. Sweet. So guys, remember, hey, look at your unit circle. So right now, you don't have to draw this. Just look at your unit circle with me, all right? So let's kind of figure this out. Does everybody see that angle, and you guys see this angle, and then this one right there? Let's take a look at the degrees. What degrees do you think A would be if we were in degrees? Yeah, 30. Perfect. 30. From here to here is 30, okay? What about from here to right there? What would you guys say the degrees is for this guy? You're right, 210, because look, this is 180, right? Add 30 degrees, that's 210. Great guess. I mean, not guess, but good result. Now, right here, guys, we're adding 30, right here, 30 to 270, which gets us what? A total of 300. Now, let's convert these to radians. Ready? Here's what I want you to do. In your journal, right now, put 30 degrees, put 210 degrees, and put 300 degrees. And what we're going to do is we're going to convert this to radians. We're going to convert these three super fast. What I want you to do is I want you to multiply each of these by pi over 180. This times that, this times that, this times that. Okay? So what I want you guys to do right now is take all of these and multiply them by what? By what? Pi over 180, and come up with what theta is in radians. So that's what I want you guys to do right now. I'm going to pause the video so my students can get me their answers, and we're going to fill them in, see if they get them right. All right, so for this radian, if we did 30 times pi over 180, you should have gotten pi over 6. If you did 210 pi over 180, what does that reduce to? That should be, I think it's 6 pi over 5. If I do 300 over 180, let's see here, what would that be? I'm just going to check them real quick. We got what? 210 over 180. Make sure I got that right. That's 7 over 6. My apologies. That's 7 over 6. 7 pi over 6. All right. And then right here we got 300 over 180. And that's 5 pi over 3. So we're going to put 5 pi over 3. So these are where the radians are, okay? So right now, this is going to be my first answer. This is going to be my second answer. This is going to be my third answer. This is A, this is B, and this is C. And what did we do each time? We just took our degree. Whatever we had, we took our degrees every single time, and you multiply it by pi over 180 to get your radians. Okay? So right here, let's take a look at it. A is what? Pi over 6, right there. Okay? B was 7. Where was it? Oh, wait. Hold on. I don't see it. 7 pi. It's got to be, I guess it's got to be 7 pi over. That's the only one that's reasonable. We estimated it to be 7 pi over 6 because we thought that was adding 30. But I guess it's not adding 30 degrees. I guess it's adding it less. It's close to it. So I'm going to choose 7 pi over 5. Or is it 8 pi over 7? Hold on. Let's do 7 pi over 5 and 8 pi over 7. Let's do 8 pi over 7 and 7 pi over 5. Multiply both of these by 180. Okay? Can you guys do that real quick? Do 7 over 5 times 180 and 8 over 7 times 180. We'll see which one we agree with most. Okay? So 8 over 7 times 180, we get 205. Close to 206. And the other one was what? 7 divided by 5 times 180. That gets us 252. Oh, it's not 252. I'm going to choose that one. That's got to be where it is of those choices. All right? Because it's just past the it's close to the 210. So we're going to choose this guy. And then this one, what did we say that one was? 5 pi over 3, right? So what did we just do there? Because what did we estimate it? We estimated it to be at 7 pi, because we thought it was 210 10 degrees, but it ended up being what? Close to 206 degrees. So that's why we had to make a little adjustment on the fly. All right, so I think we got them all. Yep. Yep. And yep. Okay. All right. Now this one right here, what I want you guys to understand, you can actually go backwards. It just says, what's the value of y? So if we go all the way around, ready? If we go all the way around, how far is that? If I say, what's 2 pi, which is all the way around, right? If I take away a pi over 6, what's 2 pi, or what's 2 take away 1/6? What do you guys think we'd be left with? If I took 2 and I took away 1/6, what do you think? Would you guys agree 12 over 6 is 2? If I take away 1/6, what do I have left? 11 pi over, I'm going to have 11 pi over 6. If we're looking for the point A, which is the y-coordinate, we're going to say it's the sine of 11 pi over 6, because it's always going to be the sine of that point. So what did I do? I said all the way around is 2 pi. What did I take away? I took away pi over 6, and that left me with 11 pi over 6. All right? Just remember, guys, all the way around the circle is always going to be 2 pi radians. So sometimes you can just simply take what you need away from the 2 pi. All right? All right, last question. Which of these coordinates is equal to the cosine of 2 pi over 3? So what are we going to do with the cosine of 2 pi over 3? It's the x-coordinate, right? The x-coordinate of 2 pi over 3. So what do we multiply 2 pi over 3 by? 180 over pi. So I'm going to, 3 goes into 180, a total of 60 times. The pi's cancel out. I'm looking for 120 degrees. So which goes to 120 degrees? Does A go to 120 degrees? Does B go to 120 degrees? Or does C go to 120 degrees? B. So that's why I'm going to choose answer choice B, because the cosine of 2 pi over 3 is putting me at what? 120 degrees. So I'm going to choose B. Guess I got to choose the x-coordinate of B. And that's it. Okay? So make sure when you guys are doing these problems, the one thing you got to have in your journal, guys, you got to have this. You got to have this, and you got to have this right here. This is super important. Be able to go from degrees to radians and radians to degrees. So hopefully this was helpful. If you watch it enough times, you will learn it. If you don't watch it, you won't learn.